And yeah, so I'm going to be talking about a story of sharing open data on GitHub with FME, once everybody's settled. This story takes place in La Rioja, the state in Spain. I think many people know about this state because of what? The wonderful wine that comes from the state of La Rioja. And this story came to us. There's a couple of folks that work for the Spatial Data Infrastructure Group in the state of La Rioja, Spain. This is Ana Garcia de Vicuña. Actually, her full name is even longer than that. And Pablo Martinez Perez. And these two have approached us, contacted us at Safe Software, said they'd really like to come to the FME International User Conference, but things being as they are, they couldn't make it. So they asked if we could present this story for them. And we thought it was a fantastic story, so we're going to present it for them. But what I would like to do is give a wave to them back there in Spain. So the word for wave in Spanish is what? Hola. So what I'd like everybody to do is turn around, face the camera at the back, and we're going to say, Hola, Pablo y Ana. Like that, okay? Everybody ready? 1, 2, 3. Hola, Pablo y Ana. Great. Thanks. And if anybody got a picture of that, you could tweet it to IDE Rioja. They'd love it. They're probably asleep right now, but. So in fact, we liked this story so much, we used it in the FME World Tour, so some of you may have seen this already. Interestingly, this is the second year these guys were in the FME World Tour. Last year, they did a fantastic presentation on using FME to process rapid eye satellite imagery. At that time, some of the more sophisticated satellite imagery processing tools could not deal with rapid eye imagery, so they did it with FME, creating some vegetation index classification that's a fairly complex thing to do with FME with the raster expression evaluator transformer. So that story is on blog.safe.com. You can see that story there. And who can forget, do I have it open? I didn't. The year before that, they also presented what was a fantastic workflow of making orthophoto map series in PDF with FME. And I couldn't help but show that again. That was done with FME. I won't say that's easy to do with FME. It's not. They have scale bar, surround. But once they got that workflow done, this was for a map series. So really nice looking map series. And I'm told there's some work happening on it's a layout tool for PDF in 2015. So this will get easier, that kind of workflow. But what we're actually talking about is sharing public data. This is another story about sharing data. The IDE Rioja group, they were really committed to their mission, which is to share the data that is open from the state with the public. I would say they've taken data sharing to the next level. A key thing here is that they're using the Creative Commons license. So this is a license typically used in open source software. They wanted to apply that to their data sharing agreement so that anyone, what it basically means, this particular Creative Commons license that they are using, is that anyone can use the data. You can make money from the data. You can make other products from the data, as long as you credit them and notify people if you've changed it in any way. So that's what they wanted to do. They've decided to do this with GitHub. Dale referred to GitHub yesterday as the cool cat on the block, I guess we could say. It's got this cat logo. So they've decided to do this with GitHub. And let's take a look at what GitHub really is. We could say that GitHub is really just a version control system. It's mainly known to people that do software development. A lot of open source software development uses GitHub. And it's a mechanism to store files and store changes or revisions to those files, keep track of who has changed what. We can commit files to a public repository. So that means files that are committed to GitHub are available to the public on a website already. So we don't have to create our own website for data that way. We can revert files back to their previous state. We can see who changed what. So this was all very useful for software development. These guys thought, let's use this for the state's spatial data. So why are they using this for the state spatial data? Well, for the same reasons. We can be sure that the most recent version of the data is available on the GitHub repository. We can have multiple people contributing to the repository and not get mixed up who changed what or do we have the latest version. The data gets pushed up to GitHub in a format that we've been kind of joking about off and on today. Well, it's not actually XML. It's XML's little brother, JSON. So it's GeoJSON, in fact. So that's why GitHub was used in this case. How does FME help? This is really meant to be an FME story. So of course, we know FME is a tool for data translation. So you can imagine that their spatial data repository, their key spatial data store is Oracle Spatial. So we can picture FME being used to translate data from Oracle Spatial into GeoJSON so that it can get moved into this GitHub repository. But first, and this is one of the things that I find really interesting about this, they decided that the list of layers they want to share, this is also an important thing that we need to keep track of the revisions. So that list of layers is also kept on GitHub. This makes sure they have the most recent version. They can check who the last person to edit it was. So the layer list is on GitHub. And when the workspace runs, it actually pulls the layer list down from GitHub, reads it with a startup Python script, and then the workspace runs. And we're sure that we are actually reading the right layers. So that's done. If we take a look here, oh, this is pretty hard to see. This is just a screenshot. I'm going to open actually the GitHub repository itself in a second. But this is just a screenshot of the layer list. It's not very interesting, but it just shows what's been checked into GitHub, the list of all the Oracle spatial tables that are going to be made public. You know, you can imagine this is an important thing to keep track of the right one. The other thing is, after the workspace runs, FME commits the GeoJSON to GitHub in a shutdown TCL script. So this is kind of the other interesting part of it. Actually, I'm going to do the obligatory show the complicated workspace, although it's not complicated at all. But the key interesting things here is that we have FME pulling the layer list down with a startup Python script, running the translation with the layers that they've decided upon, and then pushing the GeoJSON data back up to GitHub with the layers that are translated. This is actually deployed as a scheduled job on FME server. So I'll just open that up. So we'll see this workspace here. So the way the layer list is done, you can see that, it's not a very complicated workspace at all. You can see that the source feature type is set up in dynamic mode, so we can read whichever layer has been chosen from the layer list. We've got the merge filter type starred, so that will read anything. And if we look in the Oracle reader here, this is a fairly common way to do things. Every reader in FME has a parameter called feature types to read. So this is the parameter that determines which layers will be read by that reader. And if I open it up, you'll see that this is actually a scripted Python parameter. And right there on, I guess it looks like it's line 9, that's where they do the git pull to get that layer list that's stored up on GitHub. So that's the way that's done. Not much really happening in this workspace beyond that, beyond the translation. So we're reading from Oracle Spatial, translating to GeoJSON, and then I mentioned pushing the data back up to GitHub with a shutdown TCL script. So that's down here. We can make, here. I think we had reference to shutdown and startup Python scripts just before the break. And we also have shutdown and startup TCL scripts. So neither of these scripts are particularly complicated. Those of you that use GitHub already, you know that the commands at the command line are relatively simple to pull and push data back and forth to GitHub. So they're really just using the scripts just to fire up something that you would normally do on the command line. So in this case, when the translation's done, the GeoJSON data is pushed up to GitHub. I'll just jump back. Once they got this workflow established, you can imagine that it's nice to be able to deploy it as a scheduled job on FME server. Then nobody really needs to worry about it again. As long as the layer list is being maintained the way they want it, the job can just run. The most recent version of the data in Oracle can be pushed to GitHub. So this is just a schematic map of what I already talked about. You can see we start in Oracle Spatial. Python reads the layer list into FME. There's actually a reprojector in there. We write to GeoJSON. It's actually a TCL shutdown script that pushes it up there. So that's how FME helps. Let's just take a look at their repository. So here's their GitHub repository. We're looking at this live now. And you can see here's the feature types to read that I mentioned already, the layer list. And if I go back, their license agreement, so we can see that Creative Commons license agreement, that's also checked in. So this just happens automatically. When you push stuff to GitHub, you've got a website that has all of your data in it. So if we look down here, here's all the GeoJSON layers. They tell us when they were updated. And we can see all the different layer names. And there's one I just want to click on here. Where did it go? Arboles singulares. I like that one because I think that means individual trees. Do we have any Spanish speakers? Does that sound right? Arboles individuales. And here is really the magical thing about this. The magical thing is that when GeoJSON data is published to GitHub, it automatically becomes a web map. And this is because GitHub has implemented a well-known JavaScript library called Leaflet.js. So when we click on a GeoJSON layer in the GitHub repository, there it is. It's mapped. It's OpenStreetMaps in the back, a little difficult to see because of the light. But we've got our singular trees or individual trees layer map. We have automatically a web map application really for nothing. So these guys, you know, I think we know the economic situation in Spain. They're pretty much an open source stack at this organization. FME is something that they use to do this, but otherwise, we have a web mapping platform that really has cost very little. You can see that any of the JSON attributes that were included in the JSON layer that FME wrote are showing up in the little attribute tables there. So really, really powerful tool. Moving forward, I just want to pop back to the slides a sec. There's a Chrome extension, GeoJSON.io, that actually lets you edit GeoJSON files live in Chrome. I'll show that in a second. So with that functionality, IDE Rioja is planning to kind of open it up a bit more for collaborative editing of some layers where it makes sense that people in the public or people at other organizations can collaborate and contribute edits to the data source. So you can see that this is, not only is it a very, in my opinion, a very smart way to share public data, it's a great way to allow collaboration on data moving forward. So if I look back to the repository there, I've actually got that GeoJSON extension, GeoJSON.io in my Chrome browser. So there's the same data layer. You can see the JSON on the right. I can click on individual features. The table display is a little bit cleaner, and you probably can't see that, but I can add rows. This particular layer isn't going to edit because it's not open for editing, but this is where they're moving towards. This is a collaborative environment on their spatial data in GitHub. So, you know, I think that's pretty fantastic. The other interesting thing I didn't show, but GitHub's not really intended for large amounts of raster or LiDAR data. It's more of a text-based platform. But what they have done is published index maps of some of their raster data. Inside the index map, there's an attribute with a URL back to IDE Rioja so that users can download the raster data or the LiDAR data, the larger data sets directly from the organization. So lots of possibilities there. Really interesting example. So you can see that they found a great way to share public data on GitHub. They're cool. GitHub is cool. I don't know. I think this is really cool. I mentioned how FME pulls the layer list from GitHub to decide which layers to read from Oracle. We write to GeoJSON. The GeoJSON's automatically displayed in the browser due to the fact that GitHub has this leaflet.js thing implemented. And we can facilitate crowdsourcing, or whatever you want to call it, collaborative editing of these data sets. So that's the story. If anybody took a picture of us waving, tweet it to IDE Rioja. I think they would love us there.